Hi there. I wanted to talk about Module 7 just for a little bit. So the first thing I wanted to mention was someone talked about, well, quite a few people talked about memorization versus fluency. I thought there was great discussion about that and the difference between the two. One way that Joe Bowler talked about it in a conference that I saw her speak at was memorization of multiplication, for example, would look like, without any fluency understanding, would look like if you had 10 letters starting at A along the top and 10 letters starting at A along the side. And every time you paired two letters like AC, it would make H or Q. And CF would make K. And you would have to memorize those 100 letters in the middle without any connection, without any pattern. That's what we're talking about when we talk about just straight memorization, right? Everything else involves some level of understanding. So for example, instead of having students memorize that 10 by 10 grid of multiplication facts, having them understand what doubles are, and then having them maybe work with 10 times tables or maybe 5 times tables, like counting by fives. And then students would sort of work those 5 multiplications into their working memory. And then slowly students would understand that multiplying something by 6 is the same as multiplying it by 5 and then 1 more. And then slowly the 6 timetables would work into their heads. Multiplying by 9 would be like doing tens and then subtracting 1. So for example, 9 times 6 would be the same as 10 times 6, 60, minus a 6, so 54. And all of those things would slowly become automatic, and that's what Dr. Alex Lawson and a few other researchers call automaticity or automatic retrieval. So it's the idea that you have memorized it, but not by memorizing the fact, but by using it so often in your fluency and problem solving that it's now become an automatic fact for you. So I like that term, automaticity or automatic retrieval. So you can see how that works early on with multiplication. But as we get later in the grades, and a few people started talking about this later in the post, and I thought it's fantastic that people came across that, is the fact that you need a lot of teacher content knowledge in order to build questions that will lend themselves to problem solving and to thinking about facts through problem solving. Okay, so I'm going to show you a couple of questions. One that's got to do with fractions that you might do somewhere like in grade 7, and another one that's got to do with some factoring of trinomials that will come up in grade 10. Okay, so I'll show you that in just a second. So if we look at this question here, we have 3 3/8 liters of maple syrup. Each bottle holds 3/4 of a liter. How many bottles can you make? So traditionally, we would want students to recognize that, well, I want to know how many 3/4 I can fit into 3 3/8, so that's division. So I'm looking for 3 3/8 divided by 3/4. Well, 3 3/8 is 8 times 3 is 24, and 3 is 27/8, and then I multiply by the reciprocal. Don't know why, but I do. So this, you see, is a true way to solve that problem. It works, but there's no 27/8 in this question. There's no 4/3 in this question. So all of the context has gotten lost. Students aren't making sense of this question anymore. They've just converted it into numbers. Instead, if we just pose this problem to students before teaching them that division algorithm, right, they might do something like, well, here's a liter, and I'm not saying that all students would do it this way, but they might. So here's my 3 liters. So let's see how many bottles I can make out of 3 liters. So I need 3/4. So here's my first bottle, right? And then I need 3 more quarters. So 1, 2, 3. There's my next 3 quarters, right? And then I need 3 more quarters. So there's 1, 2, 3 quarters. So it's 3 bottles. And I need 3 more quarters. There's 1, 2, 3. All right, so I've got 4 bottles so far. All right, and now I have 3/8 of a liter. Well, if there's a liter here, right, we could split it up into, so first of all, I know that this would be 1 bottle, right? But I don't really have that. I have 3/8, right? So if I take this and split it into 8s, right? And I've only got 1, 2, 3/8. Well, you can see that that's 3 out of 6 parts. So that's a half a bottle, right? So my answer is 4.5 bottles. All right, so a lot more thinking that went into that and a lot more sense making, right? And I'm not saying that we'd never get to this. I'm just saying that it takes a lot of understanding to be able to do that while understanding what we're doing, okay? I'll show you one other problem. So what 2 things that we multiply to end up with that trinomial? I'm not going to do this for you. I'm actually just going to leave it as an exercise for you. But my students would know from expanding that we probably had to multiply 2 binomials, right? And now the question is, what are the parts of those binomials? Also, my students would know that algebra tiles might help with this. So that means that they know that I have an x squared and that I have 5 tiles and that I have 4 unit tiles, right? And they would also know that arranging those in a certain way might help to determine what was multiplied to make it. They would probably know that this might help. Right? And so they would start thinking about that. Now, I would pose this question before we talked about factoring at all. And so students would actually be factoring just by using their prior knowledge, okay? So there's another example of how that might work in later grades. Notice that this question isn't contextual, and problem-based learning does not have to be contextual all the time. Okay, sometimes math, just for the sake of math, is super fun, and also it's important that kids understand that a lot of math is done to serve further math, and that's okay, because that's what mathematicians do. Okay? All right, so enjoy the next module. Talk soon.